Okay, so we're going to look at exponential growth and decay. These are formulas you have used before, maybe more than once in your math classes. I think you do it before you get to Algebra 2 as well, but I wouldn't swear to it. But we looked at the parent functions and some transformations last week for exponential functions. This growth and decay, the formulas look a little bit different, but really it's the same kind of thing that's going on. After we write this down, we'll talk about that a little bit. But so you have exponential growth when a quantity exponentially increases. That's why it's called growth. Would look something like this. F of x is equal to a times 1 plus r to the t power. Okay. Oh, I put x. It should be f of t. Sorry. What do you think t stands for? Time. Yeah. Okay. All right. So f of t equals a times 1 plus r to the t power. So what we had last week was just f of x equals b to the x power, right? Where this part would be like your b, and this would be x. Well, this is split up into 1 plus r, because when you very first start talking about decimals and percentages, like in late elementary school, maybe when you're start talking about tax, right? You're going to go buy an item, it's $25, and you're going to have to pay tax on it. So the first way they show you how to find tax and what your total price is you take your $25, you multiply it by the 0.0825 for tax, you find the amount of tax, and you add it to your $25, right? Absolutely nothing wrong with that process. That's usually what the receipt shows anyway, right? But instead of doing it in 2 pieces, I could just take that $25 and instead multiply it by one thing and get my final answer. What would I multiply it by? If my tax rate is 8.25%. You know what to do? So I don't have to find it and then add it to 25 if I just want to get it all at once. Well, it wouldn't be, but 1.0825. That's where this 1 plus the rate comes in. This is 100%, and then this would be the percentage of the tax, right? So when you just go ahead, instead of doing 1, like if this is my $25, and this is my 1 plus 0.0825, if I distributed that, I'd have 25 times 1, that's my $25, plus $25 times whatever the tax is. So basically, you're just adding the rates before you multiply. That's what's happening here. So after you add them, you're right back at the exponential functions we did on Thursday. So you want your total price, and you're trying to figure it out on your calculator on your phone because you're not trying to do it in your head, and that's fine. Instead of finding the tax and adding it, multiply your whole total by 1.0825. That's how much money you got to have at the checkout, okay? And that's where this is coming from right here. But then you also have exponential decay. So if it exponentially decreases, then that means I'm not adding the rate, it's being subtracted. So f of t is going to be equal to a times 1 minus r to the t power. Okay, it's a function of time. So it says where a is the initial amount, r is the growth, the rate of growth or decay as a decimal, and then t is the length of time. Okay, so there's going to be 3 parts to these answers. You have to have the function written out, f of t, and then actually use it, because it says on here write and use. So 2 different things. We're going to have the f of t that would work for anything, and then move on from there. So it says, Brooke started her career with an annual salary of $32,000. Each year thereafter, her salary increased by 2.5%. So right there, that whole increased tells you it's exponential growth. It does go on to say write and use an exponential growth function. I should have taken all those out, and I will eventually, because that tells you what to do. But you need to know from the words that are in there. So an exponential growth function to find her salary when she retires after 30 years. So f of t is going to equal, what's her initial salary? $32,000, okay, times 1 plus, what's the rate? 2.5, so I write 0.025, right, to the t power. So that's my f of t function. That is me writing that exponential growth function. Then I'm going to use it to solve the problem. It says when her salary, after she retires after 30 years, so that means I substitute 30 in for t, so this is f of 30. That's equal to 32,000. Now, I could add these together here and put 1.025 to the 30th power. Whether you add those right there or not, it doesn't matter. You can let the calculator do it. Like, that's pretty easy to add. But if it's a subtraction thing or the numbers are weird, you can just do it all in the calculator. But at this point, you can put all that in your calculator and get a number. So go ahead and do that. At any point, if there's just something you're not sure how to type or find on that calculator, let me know. Making sure you're using your parentheses correctly, right? Then rounding is a big deal here because for calculus, everything has to be rounded to 3 decimal places unless it says otherwise or it doesn't make any sense to do it. For instance, money. How many decimal places are we really going to round to? 2, right? 3 decimal places doesn't make any sense because it's money. We don't talk about money like that. So then we're going to have to answer the question in the form of a sentence. I don't get to put f of 30 equals. Nobody said find f of 30. Nobody said just find a or whatever. So I need to say blah, blah, blah. Brooke's salary, let's see, Brooke's salary when she retires after 30 years will be, all right. Hector, what'd you get? Did you do 3,200? And you did the same thing. But it's, oh goodness, I wrote it down wrong. Sorry about that. I'm sorry, I said 32,000 both. No, ask me if something looks weird. No, nobody's going to laugh at you. Look, I'm wrong all the time. Y'all can laugh at me all you want. Don't laugh at each other. I would rather you ask me and, just be something, because sometimes just when it comes out of your mouth, like, oh, never mind, I saw it. I'm sorry. I said 32,000. I wrote 3,200. And then if you copied what I wrote, that's why you have the wrong thing. So who actually used 32,000 and can give me the number? Okay, what you got, Jose? $67,122. How many cents? 16 cents. All right, y'all agree with that? Okay. It's the same thing, but it's just 1 decimal place. And sometimes it works that way, and sometimes it doesn't, so you want to retype it in, just depending on where that decimal place was. But yeah. All right, we good? My bad, sorry about that. And hey, that's the kind of mistake that we're all capable of, right? And sometimes we do that and we don't even realize, and you're like, I know what I'm doing. What the heck? So sorry about that. All right. Good deal. So then let's look at the next one. It says, and pay attention to this too. This says 30 years, and you want to make sure that this each year is that percentage. Sometimes those two words don't match, and you got to do a little bit of converting in there, so be careful with that. All right, so in 1995, a magazine had 14,000 subscribers. The number of subscribers increased, which means I'm doing growth, right, by 40% each year thereafter. Write and use an exponential growth function to find the number of subscribers in 2016. All right, so I've got f of t equals, we start off with 14,000. I will actually write 14,000 this time. Times 1, then plus, what's my decimal going to look like? 0.4, okay, because it's 40%, so it's 0.4 to the t power. Then I want to figure out in 2016, so what would t equal here? 21, right? And so f of 21 equals 14,000 times 1.4 to the 21st power. Yeah, I don't know. Now, and when you write your sentence, yours doesn't have to be exactly word for word like what mine is. It just needs to say the same things. So I could say the number of subscribers the magazine had in 2016 was what'd you get? I'll tell you. Good. Yes, and when I got that number, I had to write all the numbers down and then put in my commas so I knew if it was 16 million or 1 million or whatever. But let's talk about rounding with people, right? People, we're not rounding to 3 decimal places. Yes, it's like you got to think about, like, how many people can I fit on the bus? I can fit 48.2 people. So how many people can really get on the bus? 48, like that. I can't put stuff another person on there. So we don't round up for people unless it's like it asks about an average or whatever. But so we'll go with this, and what Michael said was 16,398,978. Yeah, but we don't hear about the 0.06, right? And when you're writing out these sentences, think about it this way. You're not saying after 21 years, because it's not always like you think 21 years from now, it's just going to keep increasing. Think about that. No, and think about, like, if this was written, if they were if it was like in 1998 that they were figuring this stuff out and they knew what it was in 95 and they're like, oh, in 2016, we're going to have 16 million subscribers. Then do you think that they could possibly have been, what could have possibly made this a bad calculation? In 98, did they necessarily know what the technology was going to be like in 2016? Like, magazine subscriptions went down quickly because we can get everything online. Like, back in the 90s, people actually had more magazine subscriptions. But we're not overanalyzing these. I'm just saying that these are where we're like making these statements like this was exactly how many people. Really, this should be like about how many or what was the prediction, that sort of thing. But that's okay. That's what we're doing there. All right, so now let's look at what's going on with Kate. It says Kate drank an energy beverage with 150 milligrams of caffeine. Each hour, the amount of caffeine in her system decreases by about 12%. All right, so that means I'm going to do an exponential decay. It does say that. It says use an exponential decay. Even if it didn't say that, we should know that from decreases, right? So f of t equals, she started off with 150 milligrams. And that's going to be now 1 minus what? 0.12 to the t power. So that's my function. And then it says after 8 hours, so that means t equals 8. So f of 8 equals 150. Now I got a couple of options here. Since I'm subtracting, it's not quite as straightforward and easy as the adding. You could leave it like that and let the calculator do it. But even though it's decimals, it's not that big of a deal, right? It's like 100 minus 12. So this would be 0.88. But again, you wouldn't have to subtract right then to the 8th power. Okay. No, because it says write and use. Like, you have to have them both.
No, like you write it.
Oh, I'm saying like right here you're putting 0.88? Is that what you're asking? No, because it specifically says write and use. This is you writing it. This is you using it. Does that make sense? And that's something on the AP exams that sometimes they're looking for. It said to write the function. We had to write the function. Then we got to use the function. Does that make sense to you? That's the difference there. So no, you do have to have both of these. Basically, everything I have written on here, you have to have written. And just because you have a calculator doesn't mean you just get to punch buttons and get a number either. So, all right. So then we can say, after 8 hours, Kate had about, all right, now, in this case, how many decimal places should we be rounding to? 3. Everything, I'm going to say this again, 3 decimal places, unless it says otherwise or it's people or money, right? So 3 decimal places. That's an AP, that's a calculus thing. We got to make sure we're used to that. So when we get, she'll have about, what'd you get? Zainab, what'd you get? Okay, but 3 decimal places. Huh? Okay, but 3 decimal places. Give me 3 numbers after the decimal. 945? Yes. Yes. Okay, good. Does that make sense? Okay, 3 decimal places. And that's milligrams. Whew. After 8 hours, Kate has about 53.945 milligrams of caffeine in her system. All right, so let's look at half-life. We've all taken chemistry, right? Okay, so you did this in chemistry and you did it in algebra 2. So half-life here means something to us. So it says the half-life of mercury-197 is 3 days. Write and use an exponential decay function to find the amount of mercury-197 left from a 50-gram sample after 20 days. Okay, so we're going to have to write f of t equals, right? So we started with 50 grams. And then it's 1 minus, but it didn't give us a rate. What's the rate here? It's 0.50, because that's what half-life is, right? So your rate is 0.5 to the t power, okay? But this is where it didn't match with like years and years, days and days. I want to know what happens after 20 days, but the half-life is every 3 days. So the rate isn't 50% every day, right? It's 50% every 3 days. So do you think this is going to be 3 times t or t divided by 3? T divided by 3. Because it's only every 3rd day, so I have to take the number of days and divide it by 3. That's my f of t function. Does that make sense? Then I get to substitute it in, and I've got f of 20, because it said 20 days, equals 50 times 0.5 to the 20 over 3 power. Careful with your parentheses there on the 20 over 3. Make sure that when you take that 0.5 to the exponent that you put the 20 divided by 3 in parentheses. Otherwise, it is not going to calculate out correctly for you. Was I supposed to do anything with that 197? No, that's just the name of it. Yeah, it's just the name of it. All right, who wants to give me what they got? 0.492? Do we all agree with that? Don't just take somebody's word for it. Make sure you're getting this too, because you got to make sure that you're typing this stuff in correctly. Okay, so there will be 0.492. That is correct, but still type it in and make sure that's what you get. Grams of mercury 197 left after 20 days. Okay. Anybody having issues? Speak up if you do, because the other day when I did this with my other classes, every single period the person I called on gave me the wrong answer every single time. And then there were other people in there that were getting the wrong answers because of how they were typing it in. It's not because they didn't know what they were doing, but are we all good? There's no shame in being wrong. It's okay. That's how we learn. All right, we all good? Got it? Got it? Okay. Now, continuous growth and decay. The word continuous, what did that tell you was what does that tell you you were having to use when you did these before? Does that remember? Does that ring a bell? Continuous. So instead of it reducing, like 25% a day or whatever, there could be continuous. Now we're still taking a snapshot at days, weeks, months, whatever. Think about it as just basically your growth. When you go to the doctor and you have a physical every year, right? So when you go and the doctor measures, oh, you grew 2 inches this year. Well, did you grow 2 inches like while you were sitting in the waiting room? No. No, you grew 2 inches over that year gradually. Like nobody actually watched you grow, right? But you are 2 inches taller now. So you were continuously growing, but at a rate of maybe 2 inches per year, because that's when we check it, not how, it doesn't just happen once. Whereas tax, like they do it, your tax happens right there at the checkout, and that's a one-time thing, every time you do it. So it says sometimes a quantity is constantly increasing or decreasing at an exponential rate, and not just after each year, month, day, hour. So the formula to the right can be used to find the balance in the account. Now this says balance in the account. It's because we usually use it for money, but it's not all about money, and these examples aren't even all about money, so that's a bad wording there. But it looks like this. I know this will look familiar to you. A equals P times E to the RT power. It's your PERT formula? Yep. Okay. So that continuous tells you that E is involved in there. And we will, I'm going to show you a little like minute-and-a-half video next day or so that explains a little bit more about E, because I'm quite sure that your understanding of E right now is like you don't have one. You just use it because your teacher said so. Okay, and that's okay, because that's as much as your teacher could do at that point. So right now I still just need you to hang on with me and just, this is what we're using, and then we're going to look into a little bit more about what we're doing. Now, we don't have a minus and a plus like we did before. This says your rate is positive for growth models and it's negative for decay models. So the sign on the R is just what changes here. So it's either a positive, it's just R for whatever, if it's, and then it's a negative R if it's decay. So this says a garbage dumpster started with 4 pounds of garbage. The amount of garbage increased by 35% each day from this point forward. Find the amount of garbage in the dumpster after 2 weeks. So again, not always accounts, because that would be a really gross account to have, right? So we start off with A equals, my initial amount of garbage is 4 pounds, times E to the rate is 0.35 times T. And then that's my initial one, and then I get to substitute it in, and it says after 2 weeks, right? So A equals 4 times E to the 0.35. Is it times 2? No, times what? 14, because it says 35% each day. So 2 weeks, that's where I have to have that 14 in there. And again, be careful with those parentheses. That might be the way we write it right here, but when you go to type it in, you need parentheses around this with like your multiplication inside of there, so be careful with that, okay? So type that in. Let's see how much garbage we've got here. Okay, so the amount of garbage after 2 weeks will be, now how many decimal places should we round this one to? Is it money? Is it people? Or things like, you know, fish, bears, whatever? No. So that means 3 decimal places. So Hector, you want to tell me what you got? Okay, what do y'all think about that? Y'all agree with that? Yes, good job. So 537.159 pounds of garbage. That's a lot of garbage. Okay, everybody okay with that? Any questions at all? All right, so I want you to go ahead and write this next one. Go ahead and write your initial formula. Did I misspell it? Is that what you said? Did you say I misspelled it? I didn't misspell it. Oh, you like the word garbage? That's funny. It's a bunch of garbage. What's my rate here? 0.015. Like that. So then A equals 16,000 times E to the 0.015 times 8, like that. All right, so what'd you get? Okay, y'all agree with that? 18,000? Everybody good with that? Yes? All right. So now I want you to reread the question and see if you still agree with that. What do you think? Yes. So this says the population of a town is declining. So let's say that you missed that, right? And you used this, because that's what y'all told me to write. And then in the end, you get 18,000. Well, when you should always look back and ask yourself if your answer is reasonable. If it's declining, does 18,000 make sense? No. So that doesn't mean erase everything, because that's one thing y'all like to do. Yes? Well, yeah, because if it's declining and it goes from 16,000 to 126,000, I'm thinking, yeah, there's something not right. Okay, but this, I bet you what's your decimal? Oh, okay. But negative point, that's, your parentheses might not be right on here, I'm guessing. That it may be an issue with parentheses. I'll look at it in just a second. But it's negatives, because in the end, what I know for sure before I ever start is my answer should be less than 16,000, right? Okay, so very good. Yeah, does that make sense? Was it issue? Yeah. Okay, so I can say the population of the town in 8 years will be. All right, who haven't I heard from? Juan, you have a number? What'd you get? Negative. No, not negative 18,000. You're not going to have negative people. Dude, you were not listening to our conversation. Your rate is to be negative, sweetheart. All right, somebody else. You got it? 14,190 people. Yeah, make sure you can get that number. Did you get that number, Tony, the next time you did it? Do it so you know you're doing it right. Okay. Any questions? So yeah, that declining, I got a negative percentage there. So, and then always think about reasonableness of an answer. Sometimes your numbers are so outrageous, it may not seem reasonable, but it is, but we at least know it should be less than that. Awesome. All right, now we're not actually going to do logistic growth, but I want to talk about it. Okay, it's really not that bad because we're just plugging in, I mean, it gives it to you and you plug it in, but if you ever get to Calculus 2 in college, or if you end up in BC next year, which I wouldn't necessarily encourage you to do if you're going from on-level pre-cal. Like AB, I think you're totally could be fine. BC might not be the best jump. But either way, this is something that comes up in Cal 2 and in other things, business stuff that if you're going to go into business, whatever. But what this says is, it says sometimes the quantity exponentially increases, but then levels out, approaching a horizontal asymptote. It's called logistic growth. Logistic growth. Not everything could just increase exponentially forever. So if let's just read this problem and talk about this so you can understand what's happening. It says a disease begins to spread in a town of 20,000 people. After T days, the number of people who have been infected by the disease is modeled by the function below. Using the function, find the number of people infected after 10 days. Okay, so this can't be an exponential growth that just goes on forever like this, right? Because if there's only 20,000 people in the town, it can't be like, oh, well, after 30 days, then 50,000 people are infected. Well, there's only 20,000 people there, right? So there has to be some sort of different model where this is kind of your limit. That's the most it could be. So that's what logistic growth is, when not everything can just increase exponentially. There has to be a limit because there's a certain amount of people. By the way, the answer to this problem is kind of a little scary. It's 18,414. It's almost the entire town. Yeah. But all you really have to do is it gives it to you, substitute it, and it's not even worth our time. But I just wanted to at least mention what logistic growth is. Okay? Are we good? Any questions? Awesome. Go ahead and glue those in or tape them in right now.